Hello, 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 everyone, and welcome to Math This Monday. It's Mr. Taco. I am here. Yes, there's a goatee on my face. I shaved it to see if anybody in my class would notice in morning meeting, and literally no one said anything. I'm as befuddled as you are. Clearly, I'm going to have to go bolder with my facial hair choices tomorrow, because otherwise my class isn't noticing what I'm doing. And that's really all I'm here for, right? Is to get attention, because it's all about me as the teacher. Duh, of course, okay? Today, division, using repeated subtraction, okay? We're going to get into division of decimals, division with decimals in a little while. But let's review some of the strategies that we learned in 4th grade regarding division, so we kind of have a stronger sense of where we're at when we add that decimal place. You're going to need something to write on, something to write with. There's the I cans down there. They say I can divide a dividend into equal groups using repeated subtraction, and I can represent a remainder as a fraction. So, to start representing division, we have some dots up on the board. We're going back to dots. I love dots, okay? All grades use dots, okay? Don't be afraid of dots. Like using your fingers. Do not be afraid of using your fingers in math, okay? It is a great thing that we have counting objects with us at all times if we need them, okay? Don't be afraid of them. We have 1, 2, 3, 4, 5, 6, 7, 8 dots up here. There's our dividend. There's our stuff that we're dividing, okay? 8 divided by something, the number of groups we're going to divide it into, and then how much are in each group. To start, we're going to go 8 divided by 2. 2 groups, okay? And remember, the key with division is we have to have equal groups. If we don't have enough to make equal groups, I dropped my pen, we have to stop right there, okay? So let's make some equal groups. We'll put 1 in each group. We'll put another one in each group. We'll put another one in each group. And we'll put another one in each group. Okay, a couple of very scared individuals. That one's confused. That one's angry. All right. We have 8 divided by 2 equals how many in each group? 4. Okay, so again, that's what we're talking about. When we're talking about division of fractions, same thing, right? Taking our dividend, putting that dividend into 2 equal groups. In fractions, it was less than 1 group, okay? And then how much is in 1 group? 4, in this case, okay? Simple as that. If, let's try a different divisor here, okay? We'll keep our 8. Let's go 8 divided by 3. Okay, now we're going 3 equal groups. Okay, so let's start. This is our deal the cards method here. 1, 2, 3. 1, 2, 3. And, oh. Well, we only have 2 left, but we have 3 groups, and we can't do it equally yet. So, right, we could give our answer as 2 in each group with a remainder of 2. Or, let's go further. Because we have been working with fractions all year, let's think about this here. We have our 2 things, and we're dividing it by what? 3. And remember how fractions are actually division in disguise? Right? 2 divided by 3. 2 divided by 3. Okay? So what are we saying here? That if I divide this into thirds, if I divide these 2 into thirds, that 2/3 will go in each group? Let's get wild. All right. I know. Have you ever seen your teacher destroy some dots like this? Those are not even thirds, but that's fine. You get the idea. Oh, that's much better. Aha. So now we've got thirds. Oh no. Ta-da. So now we can take, if we take 2/3, put them in each, now we've got equal groups. Now we've got 2 and 2/3 in each group. So we can give our answer in 2 and 2/3. This is why I've given this shortcut before. You take your remainder and you put that as the numerator, and then you use your divisor as the denominator. That's mathematically why this works, right? So if it's, something divided by 6 with a remainder of 1, you can give the remainder as and 1/6. Don't give it as remainder 1/6, right? But give it as blank and your fraction. So in this case, it's not 2 remainder 2/3, it's 2 and 2/3, because 2/3 can go evenly into each group, okay? If you're going to give it 2 remainder something, you would say remainder 2, because there's 2 dots that couldn't go into a group evenly until we broke them up. So that's how you give your remainder as a fraction. Okay, on the exit ticket today, you can do either. But what if, instead of just having 8 dots, we had a much larger dividend? Let's keep our divided by 3. Let's keep our divisor as 3. Instead of 8, though, we're going to go 88. 88 divided by 3 equals blank. Now, we're going to keep our 3 groups, but what I want us to think about is, could we just go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12? We could. We certainly could. But all the way up to 88, that's going to take a while, right? Let's think of some shortcuts. Okay, and let's think of this idea that when you are dividing into equal groups, let's say we had our 6, okay? When I divide, put 1 in each group, how many do I have left? Right, this is why repeated subtraction works here, okay? Because essentially what we're doing is we have our big pile of stuff. In this case, we have 88 things. We're going to divide some out into groups. And then we need to know how much we have left to divide out that we haven't divided already. That's why we subtract, okay? So we could theoretically go 88 minus 3 and put 1 in each group. Then 85 minus 3, put 1 in each group. 82 minus 3, put 1 in each group, right? Over and over and over again. But let's think with our mathematical brains here. Couldn't we take a whole big pile of them at once and push them in? So let's think about this. Could we do 10 groups at once? Could we say, I'm going to put 10 in each group to start. 10, 20, 30. So I've taken 30 of my 88 and I've divided them out. So how much do I have left? So let's keep track over here. Number remaining. Okay, 88 minus 30. We have 58 left. Could we do 10 again? Sure, let's go for it. 10, 10, 10. So 10, 20, 30. We've now divided out 30 more. So let's subtract 30 more. And we're left with 28 remaining. Now, can I do 3 groups of 10 again? No. Why? Why can I not do 3 groups of 10 again? Because we've only got 28 left. I can't subtract 28 or 30 from 28. We're not working on negative numbers yet, and negative numbers don't really help us here. Okay, so let's think of something smaller. Could we go 5 at a time? 5, 10, 15. Let's do it. Okay, so 28, I'm going to scoot it over here. 28 minus 15. 8 minus 5 is 3. 2 minus 1 is 1. I have 13 left. How many groups of 3 can I make with 13? Let's use our multiplication table here. Let's look at our 3's row. You can make one group, makes 3. If I add 2 to each group, that makes 6. 3 to each group makes 9. 4 to each group makes 12. 5 to each group makes 15, and that's too much. So let's go back. Let's put 4 in each group, because I know 4 times 3 is 12. And I have 1 remaining. Can I take that 1 and put it into 3 equal groups? I can if I break it up into thirds, huh? Because 3 thirds equals 1. Or I can just use my remainder shortcut up the top, which I'm going to do. So let's think about now how many are in one group. 10 plus 10 is 20. 5 plus 4 is 9. 20 plus 9, 29. And I had 1 remaining. So let's make my remainder as the numerator and my divisor as the denominator. 29 and 1/3. So in order to do this, you're going to need to keep track of how many groups you've made, or how many in each group you've put, and then how much you have left. That's how our repeated subtraction model works here. What if we looked at it with a much larger number? Let's go to the digital whiteboard and let's check that out. So on our whiteboard digital, we're going to try this one. We're going to go big with this one. We're going to go 1,427 divided by 5, let's say, equals n. All right, where n is the number in one group. If we took our 1,427 things, put them into 5 groups, what would be the value of one group? Okay, so let's think about this. If we put, let's see, we'll make our 1, 2, 3, 4, 5. You know what? Now that I'm thinking about it, rather than making our 5 circles and putting 1 into each, let's just keep track of our groups here. So I'm going to do number of groups. Okay. And then here's my subtraction. Number remaining. Can we see that? Kind of. Scoot this one over a little bit. There we go. Does that look better? Yes, it does. Okay, so let's think about, well, I could just do 5 at a time, right? But that seems a bit long-winded for a YouTube live stream. Let's go big, right? What about 100 groups of 5? 5 times what is 100? 500. So we're going to put 100 in each group. I shouldn't have said number of groups, because there's 5 groups. Number in each group. Sorry. My bad, I mislabeled it. Number in each group, not number of groups. Okay, number in each group. So we're going to put 100 in each group. Okay, and 100 times 5 is 500. So I just divided out 500 into each group. Okay? If I were doing a visual, I'll do a visual up here. $100, $200, $300, $400, $500. Okay? 100 in each group. And now I need to take that 500 I just divided out so I know how much I have left. Okay, makes sense? 7 minus 0 is 7. 2 minus 0 is 2. 14 minus 5 is 9. Okay, I have 927 left. Could I take out another 500? You bet I could. So let's do that. 100, 100, 100, 100, 100. I've now put another 100 in each group. And I'm going to subtract another 500 to know how much I have left. 7 minus 0 is 7. 2 minus 0 is 2. 9 minus 5 is 4. 427 remaining. Okay. Now, can I take out another 5 groups of 100? No, because I don't have 500 left. I've got to pick something smaller. Let's think about this. Well, we could just cut it in half, right? 5 times 50 would be 250. I bet we could go bigger than that, though. 5 times 60 would be, well, 5 times 6 times 10, 30 times 10, 300. We can go bigger than that. Ooh, how about 400? 5 times 80 is 400. Would you agree? 80, 160, 240, 320, 400. Or 8 times 5 is 40, and then times 10 by adding a 0. So let's put 80 in each group. 80, 80, 80, 80, and 80. And 80 times 5, 5 groups of 80, that's 400. Whew, that's a good one because it gets us really close here. 7 minus 0 is 7. 2 minus 0 is 2. 4 minus 4 is 0. So we have 27 remaining to put into 5 groups. Oh, well, that's easy, right? 5, 10, 15, 20, 25. Let's make 5. 5 in each group. 5, 10, 15, 20, 25. And let's subtract 25. Gives us 2 remaining. Just 2 left. Sorry, I'm like moving the screen around all over the place here. With 2 remaining. So how much is in each group? Let's add up how much is in each group. 100 plus 100 is 200. 80 plus 5 is 85. 200 plus 85 is, well, 285. And then our remainder, how much do we have left? 2, remainder 2. Or take our remainder, make it a numerator. Take our divisor, make it the denominator. 285 and 2/5. Because if we were to take those two units remaining, break each one of them up into fifths, we could put 2 pieces in each, giving us 285 and 2/5. Okay, checking the chat. I see some 285 and 2/5. Yes. Okay, I see in the exit ticket, can we put an answer as a decimal? Does it have to be a fraction? Well, we haven't really learned decimals yet in that context. So I said just as a remainder or as a fraction. If you want to try it as a decimal, I mean, go for it. If you feel comfortable enough and you want to try it as a decimal, try it. But you don't have to today because, again, we're going to go over that really on Thursday. All right. Any last things on this? I'm going to do it one more time just to kind of show us here. So I'm going to leave my number remaining. There's all my zeros that get turned into circles. Leave my number in each group. Okay. Let's delete these here. There we go. All right. Now we're ready. Let's try one more. Let's go bigger here. Let's go 1,318 divided by, let's go 15. Okay, so number in each group. Well, let's think about this. 15 times 10. If I did 10 in each group, that would be 150. So maybe I'll even add a little addendum for myself over here. I might say 10 groups equals 150. So that means 20 groups, I can double that, is 300. 30 groups, 450. Can y'all see this? Or are we too far off? Nope, you can't see it at all. Scooting it over. So what I'm doing is I'm making a little kind of plan for myself here. I'm saying, well, 10 groups of 15, or 10 times 15, equals 150. So then I can make myself, it's almost like a little mini times table over here, right? 40 groups of 15, or 4 times 15 times 10 is 600. Okay. 50 groups, add another 150. Gives us a good start here. Let's start there. So let's start with 50 groups, and then I'm going to subtract 750. Because I know 50 times 15 is 750. Da-da-da. 11 minus 5 is 6. 12 minus 7 is 5. 568. Let's look back over here. What's less than 568 I can use? I'll use 30 groups. That's 450. Gives us 118 left. Okay. Let's go with, how about 5 groups? Because I know that looking at this one, if 50 times 15 is 750, then 5 times 15 must be 75. Eight minus 5 is 3. 11 minus 7 is 4. Okay. Then, well, I know 15 times 3 is 45. So we can't use that. So it must be 15 times 2. Let's put 2 in each group. 15 times 2 is 30. With 13 remaining. And we can't take 13 and make a group of 15 with it without breaking it up. So there's our remainder. So let's add up how much are in each group. 50 plus 30 is 80, plus 7 is 87. Use our remainder as the numerator, and our divisor is the denominator. So we end up with each group having 87 and 13 fifteenths. Will be our answer to that big, long, convoluted one. All right. Thanks, everybody, for tuning in. This was a bit of a longer one, particularly for this last sort of demonstration problem. So the big takeaways here, when we're using this repeated subtraction strategy, there's 2 things you're going to want to keep track of. How much are in each group? How much are you putting in each group? Okay. And then keeping track and keeping a running total or a running tally of how much you're subtracting out. So if you put, you're dividing by 3, you put 10 in each group, 10 times 3 is 30. You've taken 30 from your your pile of dots and you've distributed them. So how much do you have left in that pile? Use it by subtracting. Okay, give it a try. If you have questions or want some more practice problems, come to office hour. I will be there shortly. I have to go do a science observation outside, so I might be a few minutes late, but it's sunny, so it shouldn't take too long. And yeah, that's that. Thank you everybody for tuning in. I won't take too much of your time. Come to office hour if you have questions. Have a great day. Happy math.